Hi everyone. Today we'll be going over the tangent chord theorem, which will review some other great circle vocabulary that we've been doing. So just a little warm up to reinforce what you've been learning so far. Let's see how you guys are doing. Well, they're asking you to find out what measure angle COD is. Notice that it's marked as X, but it looks like it's just that one part, but it's not. It's all of this angle right here. Okay, so I'm going to use a highlighter because I feel like it looks better. So we want this whole angle right here. And in order to do that, the very first thing you should consider is, I'll leave that, is to consider what is the arc it's opening up to. So I knew that this is a central angle, so if I knew what this arc was, it'd be the same, but I don't. So I have to think, okay, so the central angle has this arc, but these other numbers over here, this angle right here, this big one that I'm highlighting, right? That angle, this whole angle right here, is an inscribed angle to the same arc. So this angle, what does this whole angle add up to? That's right, it's 47 degrees. That's 47 degrees. And if that's 47 degrees, because it's inscribed to this giant arc BD, then this big arc must be, I'm going to mark it, double that 47. So that must be, you said it, 94 degrees. And if this whole arc is 94, then the central angle, well, it's got to be the same. Okay, so we would say that this angle is 94 degrees. Okay, so you know, when the inscribed angle is 47 degrees, the central to the same angle, to the same arc, I should say, is 2 times 47 degrees. Okay, so that's 94 degrees. That was my quick explanation on that one. All right, let's move on. Now, this reviews it a little as well. It tells you that GMA is 60. JMA is 60, which it is right here. That's a central angle to circle M. So they are asking you to find JSA, this angle right here. So let's focus in on that. So JSA, this angle. So that angle is indeed, what kind of angle is that? A central angle or an inscribed angle? This one right here. That's right, that's inscribed. And an inscribed angle, if that's an inscribed angle, then you know whatever this is, this arc is double. The problem is we don't have any numbers there. The only place we have numbers, right? The only place we have numbers are right here at the 60. So my mentality is to go, well, what are you opening up to? That's a central angle. So if that's 60, this arc has to be, you said it, 60 degrees. So now I can figure out what the inscribed angle is, and that's half, and that's 30 degrees. So this angle, X, is equal to 30 degrees. Explain how you got the angle, the answer, sorry. So angle X is 1/2 of 60 degrees, and that's 30 degrees. It's half the arc. So draw a chord JA. Okay, they're giving us the next level here. They want you to draw a chord. Remember what a chord is. A chord is when you have a circle and 2 points and then they match up. So JA. So here's the 2 points. And I'm just going to draw a nice line connecting them, drawing that chord. Okay. It's a chord because it stops at the circle. Okay. Now they're asking you to find the measure of angle JAM. 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 This angle. So you might be like, what? How am I going to get that angle? Do I have to extend this or something like that? I mean, you could, but you don't really have to. You might have to go back to what you know about triangles. That's right. Do you see the triangle right there? The triangle I'm talking about. Here we go. This triangle. Let's draw that. This is M, and it's 60. This is A. This is what we're looking for. This is what we want. So I want to know what that is. I put a little question mark. And how am I supposed to do this? If I had two angles, I could. But how come I'm having an issue here? Well, I'm hoping you see what kind of triangle this is. It's a very specific type. You remember, this is a radius, right? And so is this. So you know a radius, this is the radius, and this is a radius. They're always going to be the same. So if whatever this length is, that's the same. So this is an isosceles triangle. So I know if these two sides are the same, and this is 60 degrees, that these two angles have to be the same. So I don't want to use x because I already use x. So let's say I call them both y. So I can say 60 plus y has to add up to 180. 60 plus 2y has to equal 180. So 2y equals 120. So y equals 60. Oh, what kind of triangle is this if they're all 60 degrees? That's right, it's equilateral. So angle JAM is 60 degrees. Okay, let's move on. All right, this is the theorems you're going to be learning. It's really with the tangent chord. So remember, a tangent just touches the circle once on the outside, and that's it. It can keep going, but it doesn't have to. The point is, when it meets a chord here, that chord, they meet up, it's almost like the inscribed angle theorem. So whatever this arc is, so let's say this arc, this part right here, it can be anything, but let's say it's 100 degrees. If that's 100 degrees, then this little angle in here will have to be 50. And that's how that works. Over here, that when the chord, I guess you could say, is like a diameter or a radius, more specifically a radius and a tangent meet up, it's just perfect. It makes a 90-degree angle, okay? So that's how that works. So let's use this for some of these problems. Some practice. Okay, so I have that they gave us this arc here is 124, and they're asking to find the measure of angle BAD. So BAD is this angle right in here, right? So I'll use a different color so I can show it to you. So all you have to do is say angle BAD is half of AB arc, so it's 1/2 of 124, so it's 62 degrees. So that's it. That's all you need to know. It's just like an inscribed angle. That's the tangent chord. This one, now you know it's 90, and this is 9, and this is 12, and they're not asking you for an arc, they're asking you for a length, this length right here, this long one. So what kind of triangle is this? Triangle BAO is what kind of triangle? That's right, it's a right triangle, which means I can use what theorem? That's right, I can use the Pythagorean theorem. I'm going to abbreviate, please mind, don't be upset. So that would be like a squared plus b squared equals the hypotenuse squared. So that will be, remember where the hypotenuse is. The a squared and the b squared are the things that are forming the right angle. So the right angle is right here, right? So you know that the two guys making that right angle are my legs. That we're dealing with, those are the legs. So that's 9 squared plus 12 squared equals the hypotenuse squared, which is my question mark. So that's 81 plus 144, right, is equal to x squared. If I add those up, that's a 5, 8, 225. And if you take the square root of both of these, x is equal to 15. So that's all it is. AO is 15. feet, inches, I don't know. They weren't specific. Now let's try a couple more. You try a couple, pause it if you need to, but or just watch along, however you need. So this angle here is 76 degrees. So using the tangent chord theorem, I know that this arc right here, this one, is going to be twice that angle. So then this is going to be 76 times 2 is 152. So if I complete the circle, I might say, wait, if this is 152, what do I need to complete the whole entire circle, the rest of the circle? Well, the whole circle is 360 minus 152. And I would borrow, so I have 208. So this whole thing is 208, which means this angle in here that they're asking about must be 104. Now I just want to make sure here we have a straight line, and in that straight line we have 104 and 76. Do you see that? Do they add up to 180? They do. It checks. Straight lines always do. So anyway, they were asking about that arc. I went a little further than I had to. So the arc they were asking about, sorry about that, the arc, what was it? FG is equal to 208 degrees. Okay, let's try this next one. I'll try not to get off topic there. You know, sometimes you get all happy about that. So let's see. Let's pick a different color. Ooh, I like this one. Okay, so this one is 146 degrees. So this arc here is just going to be half. 1/2 of 146 is 73. That's not so bad. Let's try the next one. Ooh, the next one's not like the half one. This is the one where they want you to know this makes a right angle, because this is where the tangent, the radius is, and it's meeting up with the tangent. So this is 4. The two legs are what we don't know, the diameter there. So it's 4 squared plus this long piece, this question mark squared, is equal to 8.5 squared. So that's 16 plus question mark squared is equal to, and you type it in, 8.5 squared, and that's 72.25. So question mark squared, I subtract 16 from both sides, and I get 56.25. Then I take the square root of that. And the square root of that is 7.5. That's it. Good job. Let's move on. Now, what the heck is this? All right. Don't give me much information, no arcs or anything, but I do see a radius and I do see a tangent, and I know when those guys meet up, it's making a right angle. So I know that I have this, wait, I don't have that length. What? I don't have this length. And I need it because if I'm going to use Pythagorean theorem, I need two sides, not one. So here's, oh, I see. What would this side be? Well, I'm going to mark it right here. So ask yourself, what must this side have to be? That's right. It's 1.5 because the radius is the same for both. They are the radius. They are going to be the same length. So now when I make my Pythagorean theorem, a squared plus b squared equals the hypotenuse squared. One side is 1.5 squared. The other one, don't say 1.5. It's this whole thing. So that's 2.5 squared is equal to hypotenuse squared. Whoops, I messed that up. Hold up. So this is 1.5 squared. I need the other leg. That's this one. X squared is equal to the hypotenuse squared, which is 2.5 squared. I realized that. So let's figure that out. So 1.5 squared is 2.25 plus x squared equals 2.5 squared is 6.25. And I can subtract 2.25 from both sides, and I will have x squared equal to 4. Perfect. So x is, the square root of 4 is 2. Oh, so x is just 2. So my question mark in this question is 2. All right, we're almost there. Okay, so now I'm going to choose a different color now. Ooh, that's an interesting green. All right, let's take a look at this. They want to know what this angle is. And I'm thinking, I'm like, I'm not really sure. This is a diameter. And this is definitely inscribed, right? So what is it opening up to? What is this, all of this? Oh, that's 180 degrees. So if that's 180, then what's this little angle? That's 90. Whenever you have something inscribed to a semicircle like that, an angle inscribed to a semicircle, that's going to be 90 degrees. All right, let's keep going. Last two. So they have angle AOB is 108 degrees. You can kind of see it in there, right? And they said find the measure of ABC. ABC, that's this angle right here. Ooh, that looks like a tangent chord. It is tangent. Well, that's the chord part, and this is the tangent. So I need this angle. Well, I can find that angle if I know what this arc is, because it's half of it. So now I go, okay, well, now I need to know that arc. They gave me this number here. So what relationship do those two have? What relationship does this 108 angle have with this arc? That's right, it's a central angle, so they are equal. So this is 108 degrees. Oh, that's great. Now I know that this arc is 1/2 of AB, which is 1/2 of 108, which is 54 degrees, is angle ABC. All right, looking good, people. This one over here is giving us, looks like such busy stuff. It looks so weird. What is this strange thing? This is a ratio that they all have this ratio. They're all being multiplied by some number, that one particular number. We can figure that out if we throw little x's with them. So you see how it says 3, 3, 4? Then for this one, it's 3x, 3x, 4x. And that's it. You label it and it all comes out to you. So, oh, wait a minute. They have x here. Do you see that they have x? I don't want to use x again. I can't. If it's already in the problem, you're not allowed to. So I'm gonna change those to y's, because if you already have x in there, you can't just put it in new, right? So I'm gonna go, okay, BA is 3y, AC is 3y, and BC is 4y. And I immediately have to look for relationship that goes with all of these. What do you know about all of them when you put them together? What do they add up to when you put them all together? You are good. It's 3y plus 3y plus 4y. All those arcs add up to a full 360 circle. So that's 610y is 360 degrees. Then divide both sides by 10, right? You're going to have y is equal to 36 degrees. Okay, and it's good that I know that I can label them all, but really, the only one I'm really interested in at the end is this one right here, because when I take half of it, I will get that angle I want because of the tangent chord theorem. So I need to know what 4y is, and I'm going to use one of my favorite colors. So 4y is equal to 4 times 36. And 4 times 36 is equal to 72, so 144. So that's 144. So this, I can cross this out and be like, you're not 4y anymore. You're actually more discovered, and you're 144. So half, that angle X is 1/2 of that 144. So angle X is 72 degrees. If you got that, you pat yourself on the back. You did a nice job, and you have an extra page so that you can make a happy smiley face and be like, I'm done. Have a good day.